Hello everyone, this video is going to be about how to perform a spatial join with points and polygons in FME. There are a few ways to do this in FME, so we're going to go through the pros and cons of each method. Now if you're not familiar with what a spatial join is, what I'm referring to is joining attributes of features by their spatial relationship. Now there are a few different spatial relationship rules we can use. Examples of some of these relationships include if the geometries are intersecting each other, if the geometries contain another, or if geometries equal another. Now what problems can spatial joins help solve? So when you're working with tabular data, you can pass attributes to another table by joining based on a common field between the two tables. So in SQL, this can be done by doing an inner join, for example. However, when there's no common attribute field, the join won't be successful. But if your data is spatially enabled, you can perform a spatial join to achieve this. Alright, so let's jump to our FME workbench. So we're going to be working with two datasets for this tutorial. My point file contains doctor location offices in Ontario, and this dataset only contains a doctor ID, longitude, latitude, and point location for each doctor. My second file is the City of Toronto boundary polygon, which has an attribute which contains the district name. The problem I'm trying to solve is to know what city administration district each doctor's location resides in. So I'm going to want to solve this by doing a spatial join to bring in the district name into my doctor location file. So the transformer we're going to use to do this first is the SpatialFilter Transformer. This transformer allows for the testing for the existence of spatial relationships between two sets of features, and routing them accordingly to where they pass or fail the test. A key feature on why I may want to use this transformer is it separates the features that pass this test into a different port than the ones that fail the test. This transformer can also be used for performing quality control on a dataset by checking out for expected spatial relationships with another dataset. We are going to use the boundary file as our filter and use the family doctor location, which are the points, as the candidate. Now it's important to make sure that the datasets are in the same projection system or the spatial filter will not work. Now let's go over the parameters of this transformer we are going to use. We are going to leave the group by feature blank. This parameter allows you to select an attribute on which groups are to be formed. So if both datasets share a common attribute and the values for that attribute was a match, it would only test where there is a match. Now since the polygon data contains multiple polygons and not just a single polygon, I'm going to use the multiple filter option, since the parameter assumes boundaries and doctor locations may come in any mixed order, and must wait until all features have entered before performing any filtering. For the pass criteria, I'm going to use the pass against one filter option, since I want to join all points that intersect any districts. Now there are different types of spatial relationship rules we can use. In FME, these spatial relationship rules are called predicates. You will have to select the predicate that best matches your join criteria. So since I'm assigning an attribute from my boundary file, which is a polygon, to a point, filter intersect candidate will work to achieve this result. I'm going to leave the boundary box to no. If I turn it to yes, it will only use the bounding box of the polygon, which will not reflect my polygon accurately since each district is uniquely shaped. Curve boundary rule can be left to default. Now in order for us to perform the spatial join between two datasets, we will have to ensure that merge attribute is enabled by toggling on the merge attribute radio button. So since I still want to keep my family doctor attributes, I will need to ensure that I use the merge filter option. I can leave conflict resolution to use candidate. I don't have to worry about there being a conflict of attributes in this join because my doctor locations do not already have this district name. So after we run this transformer, we will see that 3,792 features passed and 11,700 failed. If we inspect the pass features, we will now notice that the associated admin district for each polygon now appears. Now if we actually didn't want to separate the features that passed and failed the spatial join, we can actually use a different transformer called the PointonAreaOverlayer Transformer. This transformer has a lot less parameter options and only performs an intersect, whereas the SpatialFilter Transformer will actually work on points, lines, and polygons. Performance-wise, it is actually much faster because it doesn't test for multiple conditions and does not accept a wide range of geometry types, unlike the SpatialFilter Transformer. So let's walk through the parameters we will want to use. We will again want to leave the group by option blank since there is not a common attribute we want to use between the two datasets. We want to leave the area first set to no since we can't guarantee all the polygons will enter the transformer before the points do. We can leave the aggregate handling to deaggregate. For our spatial join to happen, we will want to ensure that our merge attributes is enabled. Again, as I don't expect a merge conflict of attributes, I can accept the default accumulation mode and conflict resolution. You will now notice an admin district column has appeared in my dataset. For the points where the intersects were successful, you'll notice that the overlap column has a value of 1 and the admin district has a value for it. All the points that were not contained within the boundary will have an overlap as 0 and no admin district value. So just to recap, we went through two different methods to perform a spatial join in FME. We used the SpatialFilter Transformer and the PointonAreaOverlayer Transformer with points and polygons. We also went through why you'd want to potentially use one over the other. So I hope this video was helpful for your spatial joins. Thanks for watching, and if you did enjoy, please like and subscribe so you don't miss out on the next video. If you have any questions or problems with your FME workbench, please leave a comment below. See you next time.